Assalamu alaikum warahmatullahi wabarakatuh. Teacher Fayyazuddin Ahmad here. A very good morning to all of you. Hope you're doing fine. Ramadan Kareem to all of you. Today we are going to start a new lesson from chapter 10. That is lesson number 2, mixtures. This is the part 1 of this lesson. This is from your science reading book, Macmillan and McGraw-Hill reading book. Can you please open the page number 458? 458 from your science reading book. Mixtures. So what is a mixture? A mixture is a physical combination of two or more kinds of matter. A mixture is a physical combination of two or more kinds of matter. It's not a chemical combination, it's a physical combination. There is no chemical reaction going on here. It's just a physical combination. Mixtures are physical changes. They can be separated by physical means. Mixtures can be separated by physical means. Let us have a look at the picture. This is the mixture of different kinds of matter with different colors. This is a mixture of different kinds of matter we have with different colors. So we can separate this mixture by physical means. We can just pick it physically and just separate it. So by physical means, this mixture is separated here. We have different kinds of matter separated here. So a mixture is a combination, that is physical combination of two or more kinds of matter which can be separated physically. Everyday mixtures, we come across many types of mixtures in our daily life. Salad is one of the examples of a mixture. So salad is a mixture of lettuce, tomatoes and other foods. We can see the lettuce, we can see the tomatoes, we can see the other foods. So salad is a mixture of lettuce, tomatoes and other foods. This is a physical combination, so you can separate it by physical means. So this mixture can be separated by physical means. Also, some breakfast cereals are mixtures of solids. All these are breakfast cereals. These are all mixtures of solids. These breakfast cereals are mixtures of solids, but when you add milk to it, when you add milk to the cereals, now this mixture is a mixture of liquid and solids. When you add milk, what happens? The mixture is now a mixture of solids and a liquid. But before adding milk, it was just a mixture of solids. So after adding milk to the mixture of all these solid cereals, now the mixture is a mixture of solids and a liquid. Yeah, these are the cereals of breakfast. Food, drinks and clothing are made from mixing different kinds of matter. We can see the drink here. It's a mixture of many different kinds of matters. So this is a drink made up of different kinds of matters. By mixing different kinds of matters, this juice is formed or this drink is formed. And also we have food here. Food is also made by mixing different kinds of matter. Different kinds of matter are used to form this, to prepare this food. And also the clothing is also made by mixing different kinds of matter. Different kinds of matter being used to form the clothes, to make the clothes. So these are the food, drinks and clothing are made from mixing different kinds of matter. Solutions are mixtures. We know that some solids, they mix easily with liquids, like salt and sugar. They mix easily with liquid, with water or milk. When you add sugar into the milk, it's mixing easily. When you add sugar into the water, it mixes easily. Also salt added into the water mixes easily. So some solids mix easily with liquids. Salt water is a solution formed when salt is mixed into water. Salt water is a mixture of salt and water. What is a solution? Solution is a mixture in which two or more substances are blended completely. Solution is a mixture in which two or more substances are blended completely. When two or more substances are mixed, they are blended completely. Like when you add salt to a glass of water and stir, then you see this salt completely disappears. It means it blended completely. Also the sugar, when added into the glass of water and stirred, then you cannot find the sugar crystals anymore. The sugar is completely dissolved. It got blended completely. So this is a solution. So solution is a mixture in which two or more substances are blended completely. Let us see that. Here the salt is being added to the water here, and after stirring it, mixing it well, you can here you can see the salt water. You cannot see salt crystals in this salt water because it got blended completely here. So this is a solution. A solution is where the substances blend in completely. Chemical properties. In a mixture, matter might lose its physical properties, but matter will keep its original chemical properties. Just now we have seen here, this is the salt. It has lost its physical property of crystal shape. The crystals of the salt are no more seen here. Their crystalness is lost. So the physical property is lost here, but the chemical property will not change. This is what is explained here. In a mixture, matter might lose its physical properties, but the matter will still keep its original chemical properties. Chemical properties only change when there is a chemical reaction. Chemical properties only change during chemical reaction. So when there is no chemical reaction, when it is just a physical combination, then the physical properties may change. In a solution here, a physical property may change, but the chemical properties will not change. Substances in a solution might have physical properties that the original substance did not have. Yes, the substances in a solution may have different physical properties than the original substance. The substances in a solution have the physical properties other than the properties of original substance. Here we see here the substance, here the salt is present in solution, but the physical property of the salt here in the solution is different than the original salt. This is what is explained here. The substances in a solution might have physical properties that the original substance did not have. Salt and water by themselves are poor conductors of electricity. Salt and water, they are poor conductors of electricity. But when you mix salt and water, when salt water solution is formed, then it's a very good conductor of electricity. This is what is mentioned here. Salt and water by themselves are poor conductors of electricity, but salt water is a very good conductor. Salt water is a very good conductor. Let us see some properties here. What are physical properties? What are chemical properties? Physical properties are like color, shape, size, density, amount, and volume. These are the physical properties. And chemical properties are flammability, rusting, burning, corrosion, and reactivity. These are the chemical properties. Just now we learned that the salt and water are not good conductors of electricity by themselves. If you take salt separately and water separately, then these are not good conductors of electricity. But when you mix salt and water and the salt solution is formed, then this salt solution is a very good conductor of electricity. Let us see. In this experiment, we have connected the electrodes, and also we have taken a bulb here to check the flow of electricity. When we took the plain clean water, it's not a solution, it's just a clean water, then there was no flow of electricity here. The bulb was not glowing. But when we added salt or acid into this clean water, and now this water has changed to salt water, the solution, now the electricity starts flowing. Then because the salt water is a good conductor of electricity. We'll see here the bulb is glowing. It means this is the salt water, the salt solution. This salt solution is now conducting the electricity. There is a flow of electricity through this salt water. So this is showing as as the bulb is glowing, this is proving that the electricity is being conducted. Also here we have another experiment here. We have taken a 9 volts battery, and we have connected each pole of the battery through a cable, through a wire, to a water container, a container with pure water. First of all, we have taken clean water. We have taken clean water, tap water, and we have connected the battery, each pole of the battery is being connected with a wire and to the container, to the clean water. Initially, when we connected both the poles to the clean water, there was no change at all. But once we added salt to this water, what we can observe is the bubbles coming out of the cables, coming out of the wire ends. So this shows that there is the flow of electricity now in the salt water, which was not there before adding the salt. So in the clean water, there was no bubble, there was no flow of electricity. Now after adding salt, the bubbles started coming out, showing that there is a flow of electricity. The salt is an important electrolyte in our body. It helps to transfer the electrical signals. It helps carry the electrical signals, and also it helps the proper functioning of muscles and nerves and brains in our bodies. Salt is an important electrolyte in our body also. Alloys. What is an alloy? It's a mixture of two or more elements in which one of the elements should be a metal. Alloy is a mixture of two or more elements. At least one of the elements is a metal. Yes. Alloys can be stronger or more flexible than the substances that formed them. Alloys can be stronger or more flexible than the substances that formed them. We have seen gold. Gold, it is an alloy when it is formed into the ornament. But before forming an ornament in original form, if you just take the gold metal, it is not that flexible. The gold ornaments are the gold by itself is not so flexible. But when you make it an alloy, when you mix copper or silver to gold and make it an alloy, then it's easily flexible. Now it can be shaped into different kinds of ornaments. So that is the difference. When you just take the substance itself, it may not be so strong or it may not be flexible, but when you mix it with other substances, other elements, then it can be flexible and also more stronger. So alloys can be stronger or more flexible than the substances that formed them. The common alloys which we come across in our daily life are steel. Steel is an alloy formed of iron and carbon. Iron is a metal and carbon is a non-metal. So steel is a combination of a metal and a non-metal, and it's an alloy. Bronze is also an alloy. It's a combination of copper and tin. Bronze is an alloy made of copper and tin, a combination of two metals. Copper is a metal, tin is a metal. So by mixing two metals, bronze is formed, an alloy is formed. And also another alloy which we come across in our daily life is brass. Brass is a mixture of copper and zinc. These two again are metals. So steel, bronze and brass, these are alloys which we come across in our daily life. We can see the items made of steel here. All these items are made of steel. Here all these items are made of bronze, and here all these items are made of brass. These are the common alloys. Yeah, thousands of years ago, people discovered how to make bronze by mixing melted copper and tin. Bronze is an alloy made of copper and tin. We know this mixture of copper and tin forms bronze. So thousands of years ago, it's a very old tradition. Thousands of years ago, people have discovered how to make bronze by mixing melted copper and tin. So bronze is a kind of solution called an alloy. This is the way thousands of years, people started making bronze. They heated the metal first, and they first formed up molds with the different molds of different shapes which they wanted. So they heated the metal, they transferred or poured that metal, the hot metal into the mold, and they allowed it to cool and set. So this was how they made bronze. They used the copper, they heated the copper, and the melting copper is being now added to the tin to make it a bronze, alloy bronze. Here also we see the different types of alloys we use in our daily life and their products. brass, as we discussed, is a combination of copper and zinc, and this alloy brass is more stronger than both. It's more stronger than the copper and zinc themselves. So brass is more stronger. These are the brass items which we use in our daily life. This is a brass alloy. And also stainless steel. This is also an alloy. We use many utensils of stainless steel. It's an alloy with the combination of iron, chromium, and nickel. The stainless steel is an alloy made of combination of iron, chromium, and nickel. So this is a mixture of these three elements: iron, chromium, and nickel. This is stainless steel. And also cast iron is an alloy of iron and carbon. Cast iron is an alloy of iron and carbon. It's very strong. So we also come across this cast iron furniture and different products of cast iron in our daily life. It has low melting point, and iron. This iron is more. If you take iron separately before forming an alloy, it was not that free flowing, and it was having a higher melting point. But the alloy, which is a combination of iron and carbon, it has low melting point. It has low melting point, and it can flow well. In the formation of different items, it's useful. So cast iron is an alloy of iron and carbon with low melting point, and low melting point than iron, and also it flows well. There are different items here made of alloys. Here this is a alloy brass made. It's a saxophone made of brass here, and this is an alloy stainless steel here. The stainless steel product is zinc here. This is a combination of iron, chromium, and nickel. This is an alloy made up of the mixtures of iron, chromium, and steel. And this is a gold bracelet. As we discussed, that gold is mixed with either silver or copper or any other item to make it more flexible. So gold bracelet is also an alloy, and this statue is made up of bronze. This statue is made up of bronze. Copper and tin are the two elements, two metals used to form this alloy bronze. This is a bronze statue. Hope you understood all these things. You have understood this lesson so far. Please read the lesson from your science reading textbook. Please be prepared for the remaining part of the lesson. You try to read the remaining part also. Until then, have a nice time. Thank you.